One, two, one, two, three, four.
When you talk about the same ideas of standard work in engineering, can they also be a standard in engineering? Do you do work in that area?
Most of my work at the moment is in lean engineering. And yeah, of course, yes, standards is a very important part of lean engineering, absolutely. In pragmatic terms, the first thing we try to is, first we need to define what standardizing mean in lean as opposed to the common meaning of the word. Standardizing doesn't mean everybody the same, not at all. Standardizing first means an agreement, and means agreeing on the least wasteful way to do something. It's a very weird, leanish way to look at it. This is not best practice that we impose on everybody. This is we get together, we understand not the benefits, but the drawbacks of the various muda, the various waste created by the way we work, and we agree together on the least wasteful way to do something. Which is why once we've established a standard, everybody has to keep to it because we know it's just common sense. You know, if sometimes there are lots of reasons locally not to follow the standard because say we might win a few euros. You know, typically in engineering, you'll look at this part and you say, well, we need it. If we take it off, we need a few euros. But experience tells us that if we do this, it might work in some cases, but in other cases, we have a chance that this will be disastrous. So this short, quick win could lead to huge wasteful solutions. So we keep to the standard because we know that this is, by and large, the least wasteful way to do it. And of course, as we progress, as we learn, we update these standards. So where would we apply standards in practice in engineering? The first thing would have to standardize parts. I mean, engineers have a tendency to redraw every doorknob and every bolt and nut, and because when you have a real problem in engineering, the easiest way to solve it is to draw a new part. And the first thing we look at is we look at parts that are not key parts and draw a list of standard parts. And you say, please, if you are using screws, please take a screw from these 3 screws in the list. And this is not a dead list. If you want to change something in the list, if you want to use a 4th screw, well, you just have to convince everybody that we drop one from the list, and that's fine. It's a live list. But the first thing is, like, for a certain number of parts, we have a list of standard parts. Now, it's important to see we're not dogmatic about it. So if you really need another part, go ahead. I mean, the most important thing is making the right product. But we will have an objective of how many parts we use that are standard parts or how many parts we use from the previous development. Then we have another kind of standard, which would be the architecture standards, the interface standards. For instance, if you draw a complex product, we would have a kind of an agreement that where we put all the different functions, all the different bits, so the architecture looks rather the same. And again, we agree on this architecture because it's the least wasteful way of placing different functions. And what this enables us is to define standard interfaces, which means that we can evolve the modules independently. We can Kaizen and improve. And if our new technology doesn't work, we can go back to a proven technology. But we have a lot of freedom with each of the modules because the interfaces are standard and we can fit them together. So that would be the second way I would standardize. The third way I would standardize is actually I'd look at the processes and have standard processes to make some aspects of the product. For instance, in some cases you can, for instance, for rust problems, you can go for aluminum parts, or you can go for painted parts with special process, so you can have different things and you would choose a standard one process, or certainly in the way in assembly, you can change from one development to the other, change the order in which you assemble parts without thinking about it. And this in the factory creates a big mess because then if you want to change from one product to the other, you need to change all the workstations and so forth. So you would have a standard in terms of parts assembly. And these standard processes are very important for engineers to understand quality and to reduce the production costs. Finally, we'll have a fourth, I think, style of standard, which is far more advanced, which would be the standard in terms of how you draw a part. Put it that way, I've once seen a documentary that was absolutely great about, the Jerry Mouse? Yes? Tom and Jerry? Jerry Mouse?
Yes.
And the guys explain how they drew Jerry Mouse. And they say, well, first we do a first circle for the head, and then we put in the nose and the 2 ears and then the body. And then we move in with certain features and so forth. So here you have a design standard. They don't draw Jerry Mouse starting by the tip of the nose and backwards. They draw Jerry Mouse in one way that they share, and they know how to draw the mouse. Sometimes design standards reflect functionality. For instance, I once have a great drawing master explain to me that plants grow seeking the sun. So to draw the structure of a plant, you need to draw the type of plant looking for the sun rays. So first you would look for the movement, and then you flesh out the plant. Well, again, this would be a design standard. You don't draw the tree starting from the top leaf and down. You draw the tree from drawing the movement towards the sun. So I think these are great examples of what a design standard is. It makes it very easy for people to understand what they're doing because certain functionalities are drawn in a certain way. So there are many and standards. You can have standards for everything, but essentially the idea is standards are checklists about how we do things. And we have 4 basic types of standards, which is standards of parts, because every time you invent a new part, you create a new supply chain, which is a huge cost. Then you will have standards of interfaces, which gives you freedom to innovate in the modules and still keep the product together. Then you will have standards in terms of production processes, in terms of how you make the parts. And finally, you'd have design standards. I think the huge question we have here with standards is that these are not best practices to apply. There is no question of stifling creativity. This is what is very important. That these are agreements that, at this stage, this is how we know to do the part with the least side effects, and it's an agreement. And it's certainly it's not a rule. This is not imposed. This is preferred. We argue. If you don't keep the standard, you have to make a case. But what most matters is to make the best product possible. And if the engineer thinks that he needs to get out of the standard to make the best product possible, that's completely fine. She can do it. Standards are really it's about agreement. And as you mentioned, it's important for manufacturing. It's an agreement with manufacturing about what we can make and what we can't make. But the one point I would really emphasize compared to our mental backgrounds, the standard is not a uniform. This is not the army. We're not turning everybody into automats. Standard is not, apply this and everybody the same. Standard is an agreement of the least wasteful way to do this or that.